Hello, everybody. 3 p.m. Okay. Second, I will see first. Okay. Hello, everybody. How are you doing? It's Mourad Sultan Ezouidi. Today, we're going to start to solve polynomial to the power 5. Okay. Using, let's say, the method of Mourad Sultan Ezouidi. This method is called the discriminant formula. Okay. So we proceed, learners. Okay, we proceed to continue. Okay, solving equation. Okay, in this example, it's very important for learners. Okay, for students. Okay, to start using this method. It's a new method of Mr. Mourad Sultan Ezouidi. Okay, just I will open this. Okay, so I will share now my screen. Okay, Mr. Mourad. Okay. 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 This one. Okay. Okay. We continue. Okay. Now, learners, we immediately go to the next part. Okay. Okay. I will try to adjust the stream. Then we start. Okay. So I wish everyone is ready for watching this lecture. Okay. This lecture is dealt with solving polynomial to the power 5. Okay, everyone has to learn the new method of Mr. Mourad Sultan Ezouidi. This method is very important. Okay, I will add this to the stream first. Okay, already I shared. Okay, I shared to the stream. It's sharing your screen. Okay, I put this here. Okay, now I'll put this here. So learners, we told that, okay, I will try to solve equation of order 5, okay, of order 5. I will just, okay, I will use this one, okay, copy and paste. I will do it from the beginning. Okay, 51 we told, 51, example number 51. Okay, L, okay, okay. Here, learners, I will just reduce the power. This is 5. This is 4. This is gonna be 3. Okay, this is 3. Or we'll call I'll put this here. Okay. I will erase this one. It comes 3. Oh my God. Now, this one it comes 3. Okay. I will erase this now. Okay. So this one be cancelled. So it will be x raised to the power 5 minus 111x to the power 4 plus, plus 184,815 divided by 6, the square of 6, x to the power 3 plus 23,976 divided by 6 to the power 3. Okay. This is, of course, I will try to reduce the power. Okay, no need. I will use this one. Okay. I will just. Okay, no need. I will close this one. Comes. Okay. This one. I will erase it. Erase this. Okay, no need for this. I will erase it. I will replace with x Okay, control. This is the example learners we are going to solve today. This is x, the square of x, or x raised to the power 2. Then this is, okay, x5, x4, x3, okay, x2, and this is x, okay, plus, okay, plus what learners? Plus this one, okay. I will erase what is given. So we can see that, in fact, this is a polynomial to the power 5. Okay, I can read it as x to the power 5 minus 111 x to the power 4 plus 184,815 divided by 36 x to the power 3 plus 23,967 divided by 6 to the power 3 x squared minus, I'll just, okay, 3 minus 6,823,332,837 plus, okay, plus x, of course, plus what learners, plus, okay, plus 909, okay, 9,090,400 and, no, we told the, okay, 909,000 million, thousand, okay, and 45 million, 178,666 divided by 6 to the power 5. We are going to solve this kind of polynomial learners. So here, as the power is 5, I'm going to raise this to the power 6, means I'm going to multiply my x, px, by x. So I will obtain, okay, I will just write here, I will raise, or I will multiply my polynomial to the power 5 to power 5 by x, okay, by x. I will obtain immediately by x, Mr. Mourad Sultan. I will obtain another polynomial is the same bar. I will rate it as that. It will be px equal x raised to the power 6 minus 111 x raised to the power 5 plus 184,815 over, okay, over 6 squared x raised to the power 4 plus 23,976 over 6 cubed x cubed minus, okay, minus, I'll just appear this, okay, I will give this is a color, home. So minus 6,823,332,837 divided by 6 to the power 4 x squared plus, I will just make this as that, plus, oh my god, no, plus what learners, okay, plus 909,045 million and 178,866 over 6 to the power 5. And the last term is the constant is 0. I will write as 0 divided by 6 to the power 6 equals 0. Therefore, to solve this equation or this polynomial to the power 5, you should extend the power or uh, multiply your first polynomial by x to get a new polynomial to the power 6. It's clear that this one has a no root, which is x equals 0, okay, and you should find now the other five roots, okay, of this polynomial, means that this polynomial has in fact 6 roots, okay. So let's proceed, learners. we can see that let's focus on this polynomial to the power 6. To find out the roots of this polynomial, we should determine the value of SRQ relative respectively to LRQ, where R belongs to the set of numbers -1, 0, 1, 2, and 3, 4, and 5. Okay, so we start learners. I will just close this one. Okay, now you can see that this is my the coefficient of the x terms, okay, raised to the power 5, and then 4, then 3, then 2, then 1, and then x raised to the power 0, okay, which is a constant. So now learns that we are going to use the formula of the discriminant formula. Use the discriminant discriminant formula of Mr. Mourad Sultan Ezouidi, which is this. Okay, I will use it now so that we can what we can find the S1, SR1, okay, 2, 3, 4, and 5. Okay, so just start like that. Okay, before doing this, I will just explain this one. Okay, this is my own polynomial. Okay, I will try to solve it. To find the zero of this polynomial, I will put in okay, red color, or I will make like that, not red. Okay, okay, red color. Okay, the purpose is, I will change the color so that to be clear. Okay, the purpose learners is to solve this polynomial to the power 5. Okay, here you are. Welcome to use the method of Mr. Mourad Sultan Ezouidi HSM. This method is very important for you and to find out the roots of these polynomials. So it's clear that this is a polynomial to the power 5. Okay, I will multiply this by x. I should obtain another polynomial to the power 6, but it has the same roots. Okay, so okay, this is the user. I will give you a new color. Okay, I'll change the color of this. Okay, maybe I will use this. Okay, so now it's clear for you learners that I'm going to solve this polynomial to the power 6. Okay, okay, I'm looking for audience to come in, work with Mourad Sultan Ezouidi. We'll use calculator here to find, let's say, SR over the Q. Okay, that is relative to LR of or the Q. LR here means when R is 0, it will be L. Okay, what is it? This one. L0, it will be 111. Okay, and L1, it will be okay 184,815 over 6 square, and so on. Okay, we'll use this one to find SR, but SR should be given by Mr. Mourad Sultan Ezouidi its own formula. Okay, I'm explaining this for you. Now, learners, I will use this. Okay, when k equals 0, learners, you can see that. Okay, this one should be equal to, okay, should be equal to 1. Okay, so when k equals 0, it will be the sum from 0 to 0, combination n minus r, choose r, and raised to the power r between parentheses minus l 0 of or the q, all raised to the power negative r, simply because k is 0, l, okay, l r minus 1 of all the q, which is equal to s minus 1 of r the key r, which is equal to 1. Okay, now when k equals 1, learners, we are going to use this formula. Okay, okay, I will just try to give okay, so this one, S0 of all the I is R equal to 0 to 1. Combination n minus r, choose 1 minus r, n raised to the power r times between parentheses minus L0 of all the Q all raised to the power 1 minus R times L R minus 1 of all the Q. This one gives you, learners, when R equals 0, it will be C1 minus 0, it will be C1, n minus 0, it will be n, then n to the power R is 0, it will be n to the power 0, times, between parentheses, minus L0 of all the Q to the power 1, because 1 minus R, times L minus 1 of all the Q, because R is 0, 0 minus 1 is minus 1. Okay, this is when R equals 0. When R equals 1, I will obtain Cn minus 1, then 1 minus 1 is 0, to be Cn minus 1, choose 0, n to the power 1, times, between parentheses, minus L0 of all the Q, 1 minus 1 is 0, L0 of all the Q. I will just obtain this one. Okay, so after simplifying, I will obtain, let's say, minus C combination and choose 1, L0 for the Q times L minus 1 over the Q. This is 1, okay, by convention, plus N times L0 for the Q. You can see that L0 for the Q, learners, is a common factor between these two terms. I put it outside the brackets like that. Then minus C1n plus n is 0. So it's clear that a 0 is 0. Okay. Now we proceed to use this one. Okay. I will just obtain this. I will choose which color. Okay, blue. Now let's see if it is blue. Now do not clear, Mr. Murad. Try to change it. Okay. Red. Okay, red. No, it's not good. Okay. I will use this one. Okay. So here now we can set k equal 2. We'll try to find the new formula that will give you the value of okay of what of a. So these are from 0 to 2. C combination n minus r, choose 2 minus r between 0 and 2, times n raised to the power r, times, between parentheses, minus L0 of all the Q, raised to the power 2 minus r, times L r minus 1 of all the Q. So this one is equal, the first term is, it will be combination 2 and choose 2, L0 for all the Q raised to the power 2 minus n Cn minus 1, choose 1, because when n equal 1, it will be 2 minus 1 is 1, okay, and n minus r is 1, it will be n minus 1, times L0 of all the 2 minus 1 is 1, times L0 of all the Q plus term n square L1 of all the Q. When n equal 2, this one is 1, it will be okay, it will be 1 n squared times L1 over the Q. This one, it will be 2 minus 2. A number raised to the power 0 is 1. Okay, so I will just proceed to continuing. I will get L0 of all the Q. We told it this is a common factor. I put outside the brackets, times, say, combination n choose 2, okay, minus n C1 and minus 1. So this one, learners, you can calculate, you will get it minus C1 choose 1, then combination n choose 2 times L square L0 of all Q square plus n times n square times L1. Now I will just continue. I will use this. I will use a calculator. I will write. Okay. I will use this calculator. I will write calculator. Okay. Calculator, Mr. Murad. Yes, like that. Okay. Okay. Now I will just use this one. I will tell. Okay. So I will just write here minus C1 is 1 times C2 6 is 15. I will write minus 15 times L0 of all the Q is 111 raised to the power 2, 111 a square, okay, plus 6 square times 184,815 over 6. So this one and that will be removed. Plus what? Plus 184,815. So this one, learners, should be equal to 0. Okay, so it's going to be 0. We continue. Now I will close this one. Okay, I will close it. I will put this here. Okay, so now this one, as we told S1 is 0, I will continue to find S2. For K equal 3, we should evaluate S2 of order R. So S2, learners, I will just give its own color. Okay, this is the formula that is derived from discriminant formula of Mr. Mourad Sultan Ezouidi. When K equal 2, I will just use this one. So it will be sk minus 1, 3 minus 1 is 2 of order R equal the sum that R, let's say, belongs from 0 to 3. Combination n minus R, choose 3 minus R, n to the power R, times between parentheses minus L of or the Q raised to the power 3 minus R, times L R minus 1 of O the Q. This one, learners, when R equals 0, it's clear that this is minus n to the 3, L0 of O the Q to the power 3, plus when n equal 1, it will be 3 minus 1 is 2, n minus 1, as written here. 2 n minus 1 times n raised to the power 1, it's written here, times minus L0 of order Q, 3 minus 1 is L0 of order Q to the power 2, times, okay, it will be 1 minus 1, it will be 0, L0 of order Q, okay. When now n equal 2, it will be 3 minus 2 is 1, that's why we wrote here 1, then n minus 2 is written as it is, okay, a combination n minus 2 times 1, choose 1, times n squared because n is 2 now, times between parentheses L0 of Q or the 1. Why that is negative sign? Because a negative number raised to the power odd number, it will be negative. That's why we put here negative sign. Plus when n equal 3, all of this it will be removed. Okay, so okay, it will be learners n cubed multiplied by L2 of O the cube. Now we'll just proceed to put, let's say, L0 of O the Q to the power 3 between parentheses. You can see this one. This one, L0 of O the Q squared times L0 of O the Q is L0 of O the Q to the power 3. And here we have also L0 of O the Q to the power 3 is written, so this one and that, it's called common factor. So I should put them into parentheses outside the parentheses. I will write it as 2 of R equal L0 of O the Q raised to the power 3 times between parentheses minus n choose 3 plus n minus 1 choose 2. So after, let's say, after calculation, you can see that first term is, it will be written combination 1 choose 2 or just 2 times 3n, okay, L0 of order Q to the power 3 minus C1 n minus 1 n squared, L0 of order Q times L1 plus n cubed L2 of Q. Okay, here the number, the coefficient that we can use, I will just use L0, L1, and L2 in this formula. Okay, so this formula, learners, it's clear that it was calculated, okay, while putting k equals 0. Our comes now, learners, okay, our comes now to calculate this, okay, I'll just calculate this one. I will use my own calculator. So the first term is combination 2 choose 1 means 2 times combination 6 choose 3 means 20. 2 times 20 is 40. Okay, we just write 40 times 111 to the power what? Raised to the power 3. Okay, raised to the power 3 minus what? Minus, learners, combination 4 choose 1 means 4. Okay, so minus, we told 4 times what? Times, you see this one 6 squared, and here in the denominator it's written 6 squared. This one and that common factor, it will be simplified. It will be cancelled out, so it will be multiplied only by 111. 111 multiply by what? 184,815 multiply by 184,815. Okay, negative sign is written. Okay, negative 4 times 111 times 184. Okay, negative 4 times. Okay, then plus what? Okay, plus 23,976 plus 23,976. Why? Because 6 cubed and 6 cubed, it will be cancelled. So this one, I'll just make equal sign, equal negative, okay, negative 27,328,644 equal negative 27,328,644. Therefore, I will close this one. I already calculated. I use my own calculator. So we continue now, learners. We obtain the value of S2, which is different to 0, and that is equal to 27, negative 27,328,644. Okay, now let's move when k equal 4. When k equal 4, I will use, of course, the formula of the discriminant formula of Mourad Sultan Ezouidi. Therefore, this is the discriminant formula. Okay, when substitute, let's say, while replacing L0 of the Q with 111, L1 with 18, 84, 15, okay, L2 with 23, 976, and L4. I will just now calculation, use my calculator and check the value of this. So you can see that, okay, I will just start from the beginning. We have negative 3 choose 1 times 6 choose 4. It will be negative 45 because 3 times 15, negative 45 times what? Times 111 raised to the power 4. Okay, plus what? Plus combination 4 choose 2 is 6. Okay, times 6 squared times 111 squared times 184,815 over 6 squared. You see this 6 squared, this is square, it will be cancelled out. Therefore, I will just write this, the product of this with that, with this one that is written in the numerator. Okay, we told the plus what? Plus Mr. Murad, plus Mr. Murad, we told 6 times 111 squared, of course, times 184,815. Then, after that, we have negative sign minus 3 times 111 times 23,976. This 6 to the power 3, and that will be cancelled. No need to write it or to calculate. Okay, so it's called common factor. Okay, so I'll just write minus 3 times 111 times 23,976. Okay, then you see this one plus 6 to the power 4 divided by 6 to the power 4 is 1. I'll just write the value of this. It will be minus, I'll just write immediately minus what, Mr. Murad? Minus, we told, okay, minus 6,823 million, then 332,837, then minus, we told Mr. Murad, minus, okay, minus 68, okay, 682333, then 2837. Okay, I'll just check again. This is okay, 6,823, 6,823,320 32, sorry, 1,837. Okay, I'll just write make now equal. So this one is equal to 0. Therefore, the value of S3 is 0. I'll just close this one. Okay. Now, I should find the value uh, of S4 when K equal 5. I should, let's say, uh, I should learn as set, let's say, set R, okay, equal 4, means that I will obtain the formula of, or the discriminant formula of Mourad Sultan Ezouidi. I will just start as 4 of order R is from 0 to 5. Okay, combination n minus r, choose 5 minus r, where r between 0 and 5, n raised to the power r times between parentheses minus L0 of order q raised to the power 5 minus r times L r minus 1 of order q. This one, when let's say r equals 0, it will give negative combination n choose 5 times L0 of order q to the power 5 plus when r equal 1, it will be n times combination n minus 1 choose 4 because 5 minus 1 is 4. Okay, and n minus r, the r is 1, it will be n minus 1 times L0 of order q raised to the power 4 times L0 of order q minus, okay, when r equal to, it will be combination n minus 2, then 5 minus 2 is 3, okay, minus combination n minus 2, choose 3, okay, times the square of n times L0 of order q raised to the power 3 times L1 of order q plus, okay, when n equals 3, it will be n minus 3, choose 5 minus 3 is 2, okay, times n cubed times L0 of order q raised to the power 2 times L2 of order q plus, when n equal 4 learns, it will be this one negative number raised to the power odd number, it gives me the negative sign. It will be combination n minus 4 choose 1, n raised to the power 4 times L0 of order q times L3 of order q plus n raised to the power 5, okay, plus, okay, raised to the power 5 when n equal 5, okay. Therefore, okay, so it will be n raised to the power 5 times L4 of all the q. Okay, Ibrahim, I have listen, please. Okay, reduce the voice. So therefore, this implies that S4 of all the q. I'll just close the parentheses. Okay, we told that S4 of order R is negative combination n choose 5 plus n minus 1 choose 4 all times L0 of order q to the power 5, okay, because L0 of order q to the power 5 is common factor, okay, minus combination n minus 2 choose 3 times n square, okay, times L0 of order q to the power 3 times L1 of order q plus combination n minus 3 choose 2 times n cubed times L0 of order q squared times L2 of order q plus ik or minus n combination n minus 4 choose 1 n raised to the power, let's say, 4 multiplied by L0 for the q times L3 for the q plus n raised to the power 5 L4 for the q. This one is obtained, last one, from this after simplification. So you can see, learners, the first term, this one, it's a common factor. We told that this minus combination n choose 5 plus n combination n minus 1 choose 4, in fact, is combination 4 choose 1 or just 4 times combination n choose 5 times 0 of order q to the power 5 minus n minus 3 choose 3 times n square times 0 of order q to the power 3 to the power 3, okay, to the power 3 times L1 of order q plus combination n minus 3 choose 2 times n cubed times L0 of order q squared times L2 of order q minus n minus 1 choose 1 and to the raised to the power 4 times L0 for the Q times L3 for the Q plus the okay the n raised to the power 5 times L4 for the Q. After calculation, learners, I'll just use this fact. Okay, I will use this one, learn that I will try to use that will appear with a different color. Okay, I will use which color, Mr. Murad? I prefer. Okay, I'll see this one. No, 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 not clear. Okay, again. Azra. Yes, yes, this one. Okay, now I will use this. Okay, this is my calculator. I will just erase this. So we have C4 or C14 means combination. 4 choose 1 times combination 6 choose 5. It's for 24. Okay, times 111 raised to the power 5, I think, sorry, minus combination 4 choose 3 is 4 minus 4, no, sorry, minus we told minus minus 4 minus 4. Okay, minus 4 times, you see this one, 6 square, and the denominator value 6 squared will be cancelled out. Then times 111 to the power 3 times 184,815. I'll just write minus, okay, multiply by 111 raised to the power 3, okay, raise it, multiply by 184, okay, 84, 815 plus, learners, okay, combination 3 choose 2 is 3 times this is 111, okay, okay, I will just write plus what, learners, plus 3 plus, I'll just, okay, plus 3 times what? Times 111 raised to the power 2, okay, times 23,976, okay, 111 squared times 23,976 minus combination 2 choose 1 uh, means 2 times this 6 to the power 4 over here 6 to the power 4, no need to write them because it will be 1 times 111, so I'll just write minus 2 times 111 raised to the power 1 times between parentheses, I'll just a negative sign, it will be minus 6,823 million 332,837, close parentheses, okay, minus you see this one, 6 to the power 5, 6 to the power 5, it will be cancelled, it will be 1 in fact. I'll just write this one, it will be minus, we told, minus 90, okay, 451, okay, 451, 7878866. This one, learners, should be equal to, I will use my calculator, is 0. Therefore, this one is 0 means S5 is equal to 0. Okay. Therefore, I will continue, learners. Okay. This one I will give another colors if it is possible to appear that we really calculated. Calculated. Check, check with the green color. Okay. So now it remains to set. It remains only setting k equals 6 or put k equals 6 to obtain the last value of s. R about the Q means the R is now is 5. AK means 6 minus 1 is 5. Therefore, learners, I'll just go back and identify the discriminant formula of Mr. Mourad Sultan Ezouidi Okay, to figure out this one. It is possible. If it is possible, I will try to to continue. Okay, I'll just see. Okay, in YouTube channel. Okay, okay, solving polynomial to the power of 5, Mr. Mourad Sultan Ezouidi. Okay, after extending the power to obtain the new, okay, solve polynomial to the power of 5. Yes, that's it. Okay, we continue, of course, solving this kind of extending the polynomial. Okay, it's not easy, in fact, and we hope so that all the learners can use this formula and they can find out at the same time with Mr. Mourad Sultan Ezouidi, the Tunisian researcher, mathematical teacher, to find out all the roots of this polynomial to the power 5. Okay, therefore, learners, now we can tell that I'll just okay, I will stop this one to continue completing learners. Okay, so this is it's a deep demonstration. Okay, a deep proof to find out all the zero of this polynomial to the power 5 in front of all the media. Okay, social media. Okay, and this is a gift from me to you, to everyone, to every child, to every kid. Okay, to all kids, to every student, to every learner and teacher and colleague and professor and everyone who is seeking for loving mathematics as Mourad Sultan Ezouidi is doing always. Okay, so we continue learners. Student will just tell that I want to find the value of this as 5 of order R. I will use this one. Therefore, as 5 learners is the sum from 0 to 6, combination n minus r to 6 minus r, n raised to the power r times between parentheses minus L0 of all the q raised to the power 6 minus r times L r minus 1 of all the q. When r equals 0, I obtain this fact. Combination n should 6 simply because 6 minus 0 is 6 and minus 0 is n. Okay, n raised to the power 0 is 1, no need to write it, times minus L of all the q raised to the power 6 minus 0 is 6. That's why I wrote it here. Now, when n equal 1, I'll obtain, okay, this one will be combination n minus 1, choose 6 minus 1 is 5. That's why I wrote here n minus 1, 5. Then n raised to the power 1, because r is 1. That's why it's written n raised to the power 1, or n just, times L0 of all the q to the power 5, which is 6 minus 1 is 5 times L0 of all the q plus combination. When r equal to, it will be combination n minus 2, 4. Okay, n squared times L0 of all the q raised to the power 4 times L1 of all the q. When n equal 3, it will be minus cn minus 3, choose 3, n cubed L0 of all the q raised to the power 3 times L2 of all the q, plus combination n minus 4, choose 2 because r is 4. 6 minus 4 is 2, and minus 4 is written as it is. N raised to the power 4 times L0 for the q raised to the power 2 times L3, because 6 minus, okay, 6, okay, it will be 6 minus 3 is 3, okay, of all the q minus, when now n equal r equal 5, it will be n minus 5, then 6 minus 5 is 1. Combination of n minus 1, choose 1. N raised to the power 5 times L0 of order q raised to the power 1, because 6 minus 5 times L4 to the power q. Okay, plus learners. Okay, I will just obtain this one. I will just write it. I'll just use this. Okay. Okay. Plus what? Plus n raised to the power 4. So I will write it down this one so that it will be clear for you. Okay. 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 I should count this. What is it? Okay. I will repeat again. Okay. So this one I told that should be written down. Go down. Okay. Okay. I will put this here to close this one. Okay. So you see, then minus combination n minus 5, choose 1, n to the power 5, L0 for the q, times L4 of 4bq plus, when n equals 6 now, it will be n to the power 6. Okay, this one it will be 1 times L5 of O dq. Okay, so after finishing this distribution, or after replacing r with 0 and 1 and 2 up to 6, we obtain this development. Therefore, I can see that L0 of all the q to the power 6 is a common factor between this term and that term, means L0 of all the q 5 times L0 of all the q is L0 of all the q to the power 6. I'll put this into parentheses. Outside the parentheses, it will be combination C n choose 6, this one, minus n times combination n minus 1 choose 5 times L0 for the q. Okay, this one learns after calculation. You can see that is equal to negative combination 5 choose 1 times here combination, of course, 6 choose 6 is 1. No need to write this one. Okay, plus combination 4 and minus 2 choose 4, in fact is 1 because n r now is 6. Okay, therefore times n squared L0 for the q to the power 4 times L1 for the q minus combination n minus 3, n is 6, 6 minus 3 is 3, choose 3 is 1. No need to write, but I should appear in the formula. So I should appear this to the learners after, let's say, replacing the value of r in this discriminant formula of Mourad Sultan Ezouidi. Therefore, plus combination n minus 4, n is 6, 6 minus 4 is 2, so combination 2 choose 2 is 1, but I should appear this for you. N to the power 4, L0 for the q squared, L3 for the q, minus n minus 5 choose 1, n 6 means 1 choose 1 is 1, n to the power 5 L0 for the q to the raised to the power 1 times L4 of all the q plus n to the power 6 L5 of all the q. This one, after simplifying this formula, last one, will obtain that is 1. No need to write that is 1 also. That is 1. That is the value that is equal to 1. In fact, so I'll just write minus C combination 5 choose 1. Or I just write negative 5 as you like, times L0 for the q to the power 6 plus n squared L0 for the q raised to the power 4 L1 minus n cubed L0 of all the q cubed times L2 of all the q, okay, n raised to the power 4 times L0 of all the q squared times L3 of all the q minus n to the power 5 L0 of all the q times L4 of all the q plus the last term is n raised to the power 6 L4, L5 of all the q. Now I will use this one to calculate it, okay, to find the value of okay of S5. I will just make like that. I wish that is clear for you learners. Okay, I will choose another color. No, no, it's not. This is not clear. Okay, I'll choose another. It is possible. Blue. Blue. Okay. Yes. Okay. Like the color of the sky. I'll check. Whoa, no. Not this. Okay. 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 We continue to okay, to calculate it learners the value of this. I wish that every learner everyone who is watching now my lecture, prepare with them a calculator, scientific calculator, so that he can find the exact value of Mr. Mourad Sultan Ezouidi. Okay, so learners will use this formula. Okay, I will try to make it big. Okay, I will try to make it big, learners. I will try to make it big. Okay, I will try if it is possible, of course. Yes, of course it's possible, Mr. Mourad Sultan Ezouidi. Therefore, I will just make this. If this one comes, no, it's a lot, Mr. Mourad. Okay, now I will use this one. Okay, so I will just continue calculating the value of S5, we told minus 5 times 111 raised to the power 6. Okay, then plus this one and this one will be cancelled. I'll just write this and that. Okay, I'll just write plus, we told plus 6 times, sorry, not plus 6, Mr. Murad. Okay, we told the plus 6 squared divided by 6 squared is 1 plus 111 plus 111 or 111 raised to the power 4. Okay, times 184,815. Then you see this negative sign, negative 6 cubed times 111 cubed times 23,976 over 6 cubed. This one and that will be cancelled out. I'll just write minus 111 cubed, okay, cubed to the power 3 times 23,976. Then plus 6 raised to the power 4 divided by 6 raised to the power 4. No need. Times 111 squared times a negative number. I put the negative number in front of this expression. Plus times minus is minus. I will just write minus 111 squared. Okay. Times what, learners? Times 6,823 million. Okay. 332,837, I thought. Okay. I'll just check the numbers. 6823, 6823, 3332,837. Yes. Then, okay. Then minus 6 to the power 5 multiplied by 111 multiplied by, okay, by, we told 909,045 million 178,866 divided by 6 to the power 5. You see 6 to the power 5 is written in the denominator value, and this one is 6 to the power 5. This and that will be cancelled out. I'll just write minus multiplied by 111 multiplied by 909,045 million 178,866 only. But minus multiplied by minus is positive. I will write positive. Okay, positive sign. 111 times what, learners? Times, okay, we told 90, 45, 17, 88, 66. So this one plus what, learners? Plus 6 to the power 6 multiplied by 0 over 6 to the power 6. So 6 to the power 6 divided by 6 to the power 6 is 1. Multiplied by 0, no need to write is 0. I'll just make equal sign. Equal what, learners? I repeat again, sorry. I repeat this again. It will be equal again. I will repeat again. So, minus 5, we told, minus 5 times 11 raised to the power 6. Okay, plus, we repeat it again, plus 111 raised to the power 4. Okay, times A 184 815 minus 111 raised to the power 3, of course. Okay. Mhm. Times 23,976, then minus 111 squared, okay, times what? We told 6,823,332. I'll check 8,600, 6,823 million, 332, yes, 332,837. Then plus what learns plus 111 times 1990, because minus to minus خلاص, no need to write them positive sign, just write this 6 over 5. 6 over 5 is 1. I wrote okay, 111 times this number, which is 19, 90, 45, 17, 88, 66. So just write 19, 90, 45. Okay, 17, 88, 66. This one, that will make equal sign. Plus 6 to the power 6 over 6 to the power 6 is 1 times 0 is 0. No need to write the last term. This one should be equal to, okay, equal to what, learners? Okay, it will be, okay, 30, okay, 35, 505, 35, 505, 0, 86, 0, 86, 170, 170, 203, 203. So this is the correct answer. Therefore, the value of S5 is that. I will now make comes here. I will close this one. So we obtain the same value. Okay, this one I mean learners. Okay, like that. 335555005008866117700222003. Okay, therefore we obtain the same value. Okay, now, after finishing learners calculating S minus 1 or S0, okay, now learners are just comes here, tell something. After, let's say, explaining, find S0, S1, or S2, S3, or S4, okay, and S5. So now we can resume this or summarize this to write a new polynomial to the power 6, okay? Relating, of course, to S1, S0, S1, S2, and S3, and S4, and S5. I'll come here, learners, to continue proceeding. Okay, therefore, it comes down if it is possible. Therefore, now, in other words, we got S0 of order R is equal to S1 of order R, which is equal to S3 of order R, which is equal to S4 of order R equals 0. Except, learners, S2 of R is different to 0. It will be negative 27,328,644. Okay, and this one, it can be also S5 is different to 0 because we found the value of this. Now I will use the method. Okay, so the first polynomial to the power 5 is extended to be a polynomial to the power 6, and we obtain this new value. Okay, this new value. Okay, therefore, learners, we can write a p of x equal x to the power 6 minus S0 of order r x raised to the power 5 plus, I'll just use this one, yes, home, okay. Therefore, okay, I mean this one, all of this, okay, all of this, Mr. Murad, okay, blue color. So we told that this new polynomial is obtained from the value of SR of ODQ relative to LR of ODQ, where R belongs to the set of numbers 0, 1, 2, 3, 4, and 5. Okay. Therefore, we told that this one is 0, and S1 is 0, S3 is 0, S4 is 0. It remains only S2 and S5. I will write my polynomial, okay, to the power 6 as that. X raised to the power 6 minus S2 of order R x cubed plus S5 of order R. Oh my God. Okay. I will replace, let's say, S2 and S5 with its value. I will obtain, sorry, I will obtain this. Okay, this is the value of negative S2, and the S2 is negative, negative, negative is positive sign. Therefore, I will use the discriminant of Mourad Sultan Ezouidi when n equal 2. I will obtain minus S2 when n equals 6, of course. I will obtain minus S2 of order R raised to the power 2 plus 4 S5 of order R. I will obtain my new discriminant S1 of order R dash, of course, will be minus the value of 2 raised to the power 2, okay, plus 4 times the value of S2. I will use now my calculator to obtain the value. This is, you see the last term, I will multiply by 4. I will start from the right hand side to go back to the left hand side, okay, or just starting from this to that, no problem. As this one is written, I will multiply by 4 immediately. Multiply by 4 minus what? Minus 27 million 328 644, of course, raised to the power what? To the power 2. I will obtain this value. It will be okay, negative 604, 834, 838, 197, 924. Okay, it's the same value of this negative sign, 60, 48. You can read both on the same at the same time like that. We make parallelism. Okay, it will be 60, 60, 48, 48, then 34, 34, then 43, 43, then 8, 8, then 19, 19, then 7, 9 to 4, 7, 9 to 4. Okay, I obtain the value of the discriminant. Therefore, you can see the negative sign. Okay, it's a negative number. Okay, this one means we have two roots, but raised to the power 3, not raised to the power 2, because this is x to the power 3. You can reduce and you can write put x3 equal u, and you'll obtain a point to the power 2. Okay. Therefore, learners, I will try now to use the formula. Okay. Now I will come as here. I will give another. Okay. Okay. So this one is the solution of my equation. I will try to appear here. Okay, I'll just make like that. I will cancel the subscript. Full, okay, it's clear. I will come here. I will make like that. Therefore, learners, we start from the beginning. Okay. Now I will make Control A. I will make full size effect. Full, it's better. Okay. Therefore, you can see that x to the power 3 is equal to s2 of r the r minus the root of minus s1 of r the r dash over 2. So this is the value. We told that. Okay, s2 is negative. That's why here it's written a negative number. Okay, if it is a negative sign, you can write positive, but s2 is negative itself, and you should write s2 minus root of minus s1 over the r dash, which is the value of this. Okay, which is this one. Okay, this one, the value of delta, the value of s1 of order r. Okay, I wrote it here. Therefore, we obtain roots of this. Okay, I will multiply this by minus 1, then I will try to find the value of this. It is possible, of course. Multiply by negative 1. Okay, this one, learners, is equal to this. Okay, I will try to find the root because it is inside the square root. I will make to the power 0.5, raised to the power 0.5. 2.5. So it will be equal to, okay, 24,539,000, okay, 382. Okay, of course, don't forget about the negative sign. This one I will make minus, okay, I will make multiply by minus 1, then minus 27, 328, 8, 644, then minus 27, 328, 644 equal, then I should divide them by 2. Equal, then divided by 2. Divided by 2. Okay, divided by 2. Equal what? We explain this, learners, in the beginning. So, therefore, x raised to the power 3 is equal to the last number or that whatsoever. Therefore, xk belongs to 0, 1, 2 is the cube root of the whole number. Okay, the whole number. You see the negative sign here? Doesn't written here because it's sorted out from the square root. I can write this as, okay, I can write this as, I will explain this for you to appear what we wrote, what we did exactly. I will now, minus 1, I will write it as exponential IP only. Okay, I will write here between parentheses, of course. This is, I will, minus sign will be outside. Okay, I will put here minus sign. This is minus. Okay, and I will close this parenthesis. Okay, no, not like that. Okay, so you minus 1 can be written as exponential IP. I will write here up exponential IP. I would choose one of them. I would choose this exponential IP. I pi, sorry, exponential I pi. Then I will comes back here. Okay, exponential I pi a. Okay, times what, learners? Times exponential 2 chi pi. Okay, times exponential 2i 2, okay, 2 2k I pi. Therefore, this one it will be, you see, I pi plus 2k I pi. It will be between parentheses. Okay, it will be between parentheses 2k plus 1. Okay, I pi. Okay, then I should, okay, I should, okay, this is exactly, okay. After that, when you put, uh, let's say, okay, of course, divide by 2. In fact, this is the number. Then, learners, from where it comes to pi, because the exponential to pi, to k pi, is always minus 1 raised to the power an even number is 1. Okay, so that's it. Okay, therefore, to x cubed equal this one. So xk from 0 to 2, 1, 2 is the cube root of all this number. Okay, means when you put, let's say, a cube root like that, okay, sorry, I will cross all of this. Okay, copy, or okay, equal. Therefore, I will make a cube root now, learners, cube root. Is S1, S2, S3, S4, S5. Okay, this is its own xk. Therefore, xk equal the cube root of this number that we got. Then the roots of the original polynomial to the power 6 that is written related to LR for the Q of course, is k belongs to 0, 1, 2, which is equal L0 for the q, which is 111 plus xk. Okay, therefore, this is the correct value. Okay, the first root. Okay, the first three roots of this polynomial. It remains only three other roots. Okay, so x3 to the power 3, it will be s2 to the power r minus root of minus s1 of order r dash, which is equal to negative 27,328,644 plus root of this value times 2ki pi divided by 3. Okay, because this is a cube root. Okay, this one equal to this. Okay, so therefore, the zero of this polynomial, the other three roots are written as alpha and exit k belongs to 0, 1, 2 is L0 of all the q plus xk 0, 1, 2. Of course, here 1, 2, don't forget. Okay, here also 1, 2, don't forget. Okay, good man. Okay, therefore, learners, I will just write 111 plus root of this value exponential. Mhm, mhm. We simplified. Okay, good. We simplified. It will be negative. Therefore, yes. Okay. Yes, Papa. Child, okay. After finishing, okay. Okay. Therefore, learners, we just apply this formula. So these are the roots. Okay. Okay. Now, learners, one of the learner, he will tell me, Mr. Murad, okay, this is alpha k 102 equal. Can this or that gives me this one? I mean, this or that gives me the first x equal 0 because x to the power 5. You raise this to the power 6. Okay, means that really there is an alpha that varies that its value is 0. Okay, look here. When k equal 1, okay, we'll obtain what? It will be 2k plus 1, it will be I pi, it will be minus. Okay, therefore, I will use my calculator. Okay, I use my calculator. I will just write this one 111 plus, okay, cube root. I will write this one minus 1367, okay, 631, means 13 means what? 1, 2, 3 means, okay, means 1,367,631. So plus between parentheses or minus of course, plus la plus. Okay, we told that 13 plus negative 13. Okay, negative 13, negative 13, 13, 13, 6, 7, 6, 3, 1. Okay, to the power 1 divided by 3 between parentheses. 1 divided by 3 close the parentheses. Okay, this one equal 0. You see, 111 plus the first value minus 136 6731 raised to the power 1 over 3 or the cube root. Okay, okay, so it will be what? It will be 0, meaning that in the first polynomial, learners, you can see that just okay here, meaning that the first value is 0 of this of this polynomial to the power 5 we solve it, and the other solution is that is the same. Okay, because here it's clear that x equals 0 we obtained from the last part. Okay, so thank you for listening. This is your mathematics teacher, your researcher, your Tunisian mathematics teacher Mourad Sultan Ezouidi. Hope you the best. Okay, now I will open this. I will reduce this subscript. Control A first. Okay. Okay, size subscript. Okay, thank you. Okay, okay. I will adjust one second. I will come here. Okay, I close this first. Close this first. Yes. Okay. Okay. Close this. Okay. Now, okay. One learner can tell. Okay. Which. Mm-hmm. Okay. Yeah, I'll finish now. Okay. Thank you. And I'll just. Oh, sorry. Okay. I'm still recording. Okay. Now I will save this one. Okay. Thank you for listening, and wish that this formula will be spread out as soon as possible. Not only this formula, so many formulas, in fact. And I'm with you. Okay. To understand mathematics and polynomials. Okay. Save this one as okay. Class. Save this. Yes. Replace file. Thank you. Okay. Now I will close this one. Then I will go back or go for camping. Okay, go camping. Camping. Sorry, camping. Yes, I will close this. Learners. This is your mathematics teacher, Mourad Sultan Ezouidi, is now explaining his research in mathematics, especially the difficult topic. Not only six, we got 7, 9, 10, 20, 30. Wallah, don't. I will just close this one. Okay. Close this one, Mr. Murad. Close this, please. We'll close this one. Okay, okay. Now I will close my calculator. Streaming. Okay, I will cancel this one. So thank you, learners, for okay. Of course, here this one is like that. Okay, I'll come here now. Mm-hmm. And streaming. Okay, okay. And streaming, Mr. Murad, if it is possible. And the streaming. Okay. Oh my God, I'm very thirsty.